Now, obviously, COVID-19 shook things up for a lot of businesses. And I imagine that many of our viewers will have seen quite a lot of Ocado delivery vans around their streets in lockdown. How did you have to adapt to this sudden global shock?
Well, obviously there was a massive spike, in demand, at times sort of 100-fold, and that took a bit of adjusting. You don't build spare capacity for that kind of surge, which is probably, I don't know, maybe once in 1,000 years. So it took a little bit of time just to get things back under control. But what emerged was really business as usual, but on steroids for us. Our model of a highly automated model for effectively getting groceries to our customers' kitchen tables really carried on largely unchanged. I mean, there was a few changes at the doorstep to keep our customers safe, and also a few changes in our warehouses to keep our staff safe. But really, it was you could say a great validation of our overall business model.
And how do you prepare for that sort of huge shock to the system? I mean, is there any way to do so? What will you take from this experience?
Well, I suppose one of the things that allowed our researchers and innovators to kind of carry on as close to normal as possible was the fact that, when lockdown hit and they headed home, often with 3D printers under their arms, they could connect from home to our synthetic environments, our simulations and our digital twins, which we, invested, a lot in building. And those virtual environments were extremely powerful for us. They are in normal times. They were during this pandemic. They will be in the future. But I think, there's an important message there about the kind of the enabling infrastructure that you build. That you build it for peacetime, but it can help you in times of crisis in other ways too.
You mentioned their digital twin. For those who aren't aware of that term, can you explain briefly what that is and how you use it?
Yeah, well, digital twins are kind of one member of this family of what we would call synthetic environments. So, simulations, emulations, visualizations, and digital twins. And what they're all about is about building high fidelity, highly accurate digital models of something. In our case, it's maybe a warehouse, it may be a robot, it may be our delivery process, and what makes it a real digital twin, because unfortunately the term digital twin is very misunderstood, is to take all of the data from that kind of physical thing or process, typically stream it via the cloud, and then feed it into this digital model. And there, you generate insights, you do kind of what if questions, you hopefully come out with new ways to optimize your physical systems, and then you feed that back into the physical thing, the physical twin, if you like. And that creates this virtual circle of kind of data flow and insights flowing the other direction. And that's, that hopefully is driving, greater optimization. It's letting you try out things before you build them. It's letting you attach machine learning models to those simulations to come up with optimizations that are even beyond what humans can do. And of course, data plays a hugely important part in all of that process. So that's kind of, but digital twins, you can build them, of your health service, you could build them, of your energy system, you could build them, of your transport network, and we need to now start thinking about how we build them of our planet for some of the things we've got ahead.
So most people will be aware of Ocado from the grocery shopping side of things, but you're not just about groceries. And in fact, you say you're not even really just about retail. So what other sectors and industries are you applying your technology to?
Well, the core of Ocado absolutely is about grocery. We used to just do it for ourselves. Then, of course, we've now turned into a platform business, and we're doing it for some of the largest and most innovative retailers around the world. And that's the core knitting. And that's absolutely what our main focus is on and will be on for the foreseeable future. But the division that I lead, the Office of the CTO, or Octo, we're kind of off on a different mission. But what we share in common is, the core business is all around moving, food atoms around in very scalable, sustainable, and automated ways. What I'm particularly interested in with my colleagues is moving all sorts of other atoms around in very efficient, automated, sustainable ways. And, food is really difficult because, it has short shelf life. It will crush one another if they pack them wrongly, if, irregularly shaped, has to be kept at the right temperature, all that sort of thing. So if you get good at moving food atoms around, actually, you've probably become quite good at moving other atoms. And that's really what we're trying to do. So we're off doing all sorts of research and advanced research that will flow down into the core platform. But we're also focusing on other kind of new ventures, spin-out applications, things like, vertical farming, how to transform vertical farming into something that really can feed a significant proportion, of the world's population. And why do we need that? Because we need many more efficient ways to turn photons into calories, and we need to reduce the impact, of conventional agriculture on our environment. And so, that's one area, but, ways to move baggage and freight around is of interest, sorting parcels, all sorts of things like that. And so, it's a kind of quite a mixed portfolio of things that we're working on.
Great. So when you're talking about moving these different kinds of atoms around, is it as simple as just applying the same technology to a different area, or do all these different kinds of atoms pose different challenges? Maybe you could give us one or two examples.
Well, no, it's definitely not just a question of straight kind of technology transfer. In many cases, where we start is to build, once again, a model or a simulation of the new area. So we will explore it, in a digital world before we ever start trying to do something in the physical world. And, that's really the power of this kind of core competence that we've built over the last 14, 15 years or so that we've been doing that. And then, once you've started building it and you've generated, perhaps even some of the data, you've created synthetic data to start training the control systems that will be required. The next stage is really to use what we call and others call living labs. So this is where you start to put these technologies out, into the real world, and hopefully help them mature, but in more constrained environments. And that's been absolutely crucial to what we do, with our grocery business. But it's now applicable to these other areas too. So we're still at relatively early stages. Some of the things that we were working on have probably been slowed down by the pandemic, and others have been accelerated. Because I think one of the things this crisis has taught us is, how we move things around in resilient and scalable ways is very important. And in the future, the attention is going to move from resilience, even more towards sustainability. How do we do that, but with having a lower kind of footprint, or if you like, impact, on the environment? And that's going to be really important, for net zero. And, tackling sustainable development goals and net zero goals is going to need, more data. It's going to need better models, but it's also going to need lots of different kinds of smart machines. And, one way to look at what Ocado does is we ideate, design, test, and build smart machines at scale, and then set them to work, in our platforms, but hopefully now in other areas too.
Yeah, as you say, that demand for goods to be delivered anywhere at any time obviously can have a negative impact on the environment. Is it possible to deliver that level of convenience sustainably? What technology can help us get there?
So obviously there's a lot of focus on, electrification at the moment, and other kind of clean fuels like hydrogen and so forth. And that's incredibly important. And that's something we're engaged in as well. And autonomy is going to be really important. Once again, that's been something we've been experimenting and working on for several years now. And there's a lot more to do there. And I think, once again, this crisis has created some interest within central government for accelerating this journey towards zero emission autonomous logistics. But I feel very strongly that you're not going to get the real benefits in terms of reduced congestion and better use of our roads and greater collaboration unless we think even bigger than that. And that's where this concept of building an internet of food or an internet of freight or an internet of atoms, if you like, for our country comes in. And this is the idea about how do you do, in many ways, what public cloud has done, for computing, shared infrastructure, shared standards, the ability to kind of, demand services, without having to build them yourself. And, we now take that for granted, both as consumers and as companies. Well, we kind of need to do that for moving stuff around. So common services, things that will drive collaboration and coordination across different sectors, across even would-be competitors, is going to be really important going forward. So once again, there are quite a lot of discussions going on about, that particular government at the moment. And I think, these are examples of big pieces of horizontal national digital infrastructure that we kind of now need to build. You need to build them on behalf of lots of initiatives and lots of different sectors, and even lots of moonshots, which are being talked about. So I think we've got to think really, really big, especially in the face of some of the challenges to come, because it could well be that we'll look back and see this pandemic as, frankly, just a warm-up act for some of the challenges ahead.
Talking about something like an internet of freight, presumably that would require a lot of investment as well in physical as well as digital infrastructure. Where do you even begin with a project like that?
Well, I think that you're right. A lot of it is digital. A lot of it is around, the kind of the services that do the coordination and the optimization. Of course, the first thing you do is build a simulation of it that turns into a digital twin. But you're right. A lot of it is about physical. But that physical will come in different shapes and sizes. It'll be around, better coordination of existing, vehicles and traffic. It'll be about orchestration, of autonomous vehicles of different shapes and sizes. Once again, but it may also be about more kind of radical stuff, like Hyperloop type pipes, but for moving freight around. Virtual conveyors built with autonomous vehicles. So there's lots to do in the physical world, and I suppose the place where we live in the world in Ocado is at that kind of intersection of the digital and the physical. And I think it's that kind of intersection or nexus that is really exciting, and where most, I think, of the exciting things will happen. And so yeah, lots to do in that physical world.
We're getting lots of questions in from our audience, but first I just wanted to give you a chance to speak a bit big picture. So, talking to you earlier, and you alluded to this earlier in the conversation, you said it was your dream to build a national digital twin or even a planetary digital twin. What exactly is that, and what would it enable?
Yeah, well, this is a live conversation. I mean, let's take a smaller version and build up from it. So supposing if you're an aircraft manufacturer, you might, join together a digital twin of the engines in an aircraft, the control surfaces, the airframe, and then you've got a model of a whole aircraft. And then you might want to, add to that models of airports and airlines and air traffic control systems. And then you've got a model or a digital twin of the aviation sector. And then you might want to start thinking out the rest of transport, so roads, railways, seaports, and then maybe the energy system, because you care about how all of this is powered, and then you need to worry about human behavior. So modeling human behavior in that, and how people want to travel and use those systems. So at that point you're on a journey towards building a national digital twin. And why is that important? Well, because it can create much greater resilience. It can help us, understand the levers we're going to pull policy-wise before we pull them. It can help optimize, our country in all sorts of ways. And that's a properly big kind of Earth shot, which is, as I say, getting a lot of discussion and focus at the moment. But I think that's just a stepping stone to something even bigger, which is this idea of, can you take that up to a planetary scale? Can we build a planetary digital twin, which is obviously not something the UK is going to do, but that's where you need to have, collaboration at a truly international scale, because, we're living through something that respects no borders. Well, climate change is just the same thing. It's going to require us to find ways to optimize our human-made systems and reduce their impact, but it's also going to require us to have much better understanding of the natural environment and how we can what we can do to help it heal. So that's a properly big bit. But well, as always, you have to dream big and you have to start small. And I think that's where this incremental approach of starting to glue together these different digital twins, of which companies like ours and others, build for themselves. And I think the question is, how do you get people to sort of crowdsource in? But to do that, somebody's got to build the common glue for gluing together all of these models, and that's really where I think government comes in, because we need we need somebody to build the underlying data infrastructure and other pieces of infrastructure to make all of this happen.